So let's continue with section 3.2. In the last video, we looked at a graph and answered questions. So now let's consider what would happen if we have the equation and we need to answer some questions. So our equation here is f of x equals x over x plus 1. And it wants to know, is the point 1/1/2 on the graph of f? Well, that's a pretty easy question to answer. All we need to do is take the x value and plug it in and see if it actually gives us a value of 1/2. So f of 1 is going to equal 1 over 1 plus 1. So that's going to be f of 1 equals 1/2. And if you notice, it does match. That y value is 1/2. So we know that, yeah, the point 1/2 is actually on that function. All right, for x equals 2, what is f of 2? What is the coordinate? So now all we're being asked to do is take that 2 and plug it in. So f of 2 is equal to 2 over 2 plus 1. So that's going to be 2/3. So what is the coordinate? The coordinate then is going to be 2 comma 2/3. All right. So if x equals 2, what is x? And are these coordinates on the graph? What are these coordinates on the graph of the of f(x)? So our function here, again, just to remind us, we'll put it over here in the margin, was f of x equals x over x plus 1. All right, so we need to know where basically f of x equals 2. So that essentially means we just need to plug in 2 wherever that f of x is. So 2 is equal to x over x plus 1. We just need to solve this function. So if we multiply both sides by x plus 1, we're going to get 2 times x plus 1 equals x. So that's 2x plus 2 equals x. So we get 2 is equal to, I'm going to take that 2x to the other side, get negative x. So we know x equals negative 2. So we know that when y equals 2, x is negative 2. So our point then would be negative 2, 2. All right, what is the domain of f? So in this case, we know we have a fraction, so we have to be very careful of what's on that in the denominator. We know the denominator cannot equal 0. So where is that denominator going to equal 0? Because we know that we don't want it to. So that means x equals negative 1. So we know that the graph the function is undefined at negative 1. So our domain then would be negative infinity to negative 1 union negative 1 positive infinity. What are the x-intercepts of the graph of f, if any, and what are these coordinates on the graph? Let's scoot up just a bit so we have a little bit more room to write. So we know then that the x-intercept is where it crosses the x-axis. And if it crosses the x-axis, then we know the y-coordinate is 0. So it's essentially asking us, where does the function equal 0? So we can here again solve it. I'm going to multiply both sides by x plus 1. So x plus 1 times 0 equals x. So we know anything multiplied by 0 is 0, so x equals 0. So our coordinate pair then is 0, 0. And we know that is the origin. So this one is going to have an x-intercept at the origin. List the y-intercepts if there are one, or if there is one, and of the function. So here again, we're going to do the exact same thing. With the y-intercept, we know the value of x equals 0. So y equals 0 over 0 plus 1. Y is 0. So here again, it's at the origin again. It's going to be at the point 0, 0. All right, we will talk about some applications next time.